Hi, I'm Steven. You're watching Steven Loves Science, and today we're going to begin our discussion of gases. Now, in this first video, I don't really want to get too in-depth into it or do any calculations or go over any formulas or anything, because I just want to make sure that everyone has a good understanding of what exactly a gas is and what the properties of those gases are. Now, I'm going to go ahead and directly quote the textbook, because we truly do live at the bottom of an ocean of air. So the composition of our atmosphere is roughly 78% nitrogen, 21% oxygen, and about a 1% mixture of other gases. Elements that are gaseous under normal atmospheric conditions include, all the noble gases, some of the halogens, oxygen, hydrogen, and there's a whole list of them. Now, ionic compounds aren't usually gaseous under normal conditions because they possess very high electrostatic attraction they have very high electrostatic attraction, meaning the attraction to negative to positive. So in order to bring those to a gas, you need to exert a lot of force, a lot of energy to break it into a gas and to overcome that electrostatic force. However, molecular compounds are going to gaseous state much more easily. A good example is when you boil water. Now, water, H2O, is a molecular compound and it boils at 100 degrees Celsius. And it's not that hard to boil water. Now, it's not really that easy to determine if something will be a gas because it's all about intermolecular attraction and forces. But we'll get to that when we discuss some of the concepts in Chapter 11 of this textbook. Now, the basic properties of gases are that they assume the volume and shape of their container. Gases are the most compressible state of matter, meaning I can take a large volume of gas and compress it into a much smaller volume. Now, gases will mix evenly and completely when they're combined in the same container. So a mixture of gases is always going to be thorough throughout. Now, gases obviously are going to have much lower densities than liquids and solids. So that's about it for the basic properties of gases. Now, let's talk about pressure. Gases exert pressure on every surface they come in contact with, because gas molecules are constantly moving around and banging into things, and it's that banging into a surface that causes pressure, or that is pressure. Now, humans have developed physiologically so that we cannot feel the effect of pressure around us, kind of the way a fish does not notice that it is underwater and does not feel the pressure of the water, whereas when a person goes swimming, you can kind of feel that pressure. So the SI unit of pressure, or the Système International unit of pressure, is the Pascal. And the Pascal is just PA. So 1 Pascal equals 1 Newton per square meter squared. Now, just to give you an idea of 1 Newton is like the force that gravity has on an apple. So that's the best representation I can think of. So this is the SI unit. But a lot of the times we work in ATM. So ATM is 1 atmosphere. And 1 atmosphere is the pressure that it takes to hold up a column of 760 millimeters of mercury. So 1 ATM is standard atmospheric pressure, what you'd be at like sea level. So the millimeter of mercury, however, is still used a lot, But in the gas equations that we're dealing with, we don't typically use it, and you have to convert to ATM. Now, the millimeter of mercury is also called the torr. So, the torr is named after Italian chemist Evangelista Torricelli. So that's the derivation of the unit, the torr. So millimeters of mercury and torr can be used interchangeably. So like I said, we're not going to go into any equations right now. That'll be for the next video, which I'm going to do right after this. So you just click on the next video. We'll be working with some equations. So that's about it for introduction of gases. Thanks for watching.